Here's a chemical equation that I've written. This is a substance known as carbonic acid, and this is a substance known as sodium hydroxide. This is an acid, this is a base. I think that maybe you've heard of these types of chemicals before, acids and bases. Whenever acids and bases like this combine, typically we get some ionic compound and water. You don't need to know that, it's just a little interesting fact. This looks quite complicated to balance, but I think you will see that once you understand the rules and the skills, balancing is actually a pretty easy and pretty fun skill. What I like to do is go through the equation and balance everything except for hydrogen and oxygen. Leave hydrogen and oxygen alone until the end. So I'm going to come through here, and I'm going to skip hydrogen, and I'm going to start with carbon. And I'm going to look on the reactant side. And I notice that there's only one carbon on the reactant side. Now please be careful. A lot of people make the mistake of looking at this 3 and trying to apply it to the carbon. That is not how this works. That 3 only applies to the oxygen. This substance has 3 oxygens in it, but only 1 carbon. So on the whole left side, on the whole reactant side, I only start with 1 carbon building block, with 1 piece of carbon, 1 carbon atom. Over here, on the right side, I also have 1 carbon atom. So it is balanced. I'm going to skip oxygen and come to sodium, Na. On the left side, I have 1 sodium. On the right side, I have 2. So how should I balance this? Right now, this does not satisfy the law of conservation of mass. Right now, this says, hey, start with 1 sodium and magically break the laws of the universe and get a 2nd sodium. That's not how it works. So, should I balance it like this? Should I add a subscript 2 right there? No. If I change the subscript from a 1 to a 2, then that completely changes the identity of the substance, and that breaks all the rules. I'm not saying that Na2OH reacts. I'm saying NaOH, which is a chemical compound, ionic compound. I'm saying that takes part in the reaction. So I cannot change the subscripts. That is not how we balance chemical equations. By the way, Na2OH does not even exist. So please don't make a fool of yourself and balance chemical equations by changing the subscripts. You do not change subscripts. Is there another way to balance it? Yes, remember, with a coefficient, which states the ratio in which these substances must combine and be produced. Now on the left side, on the reactant side, I have 2 building blocks of sodium. This 2 means that if NaOH is a chemical compound, I have 2 pieces of it, 2 units of it, 2 particles of it. So I have 2 sodiums, and that balances out. So I've balanced everything except for hydrogen and oxygen. And now I need to come back and balance hydrogen and oxygen. So I'm going to come through here and count up all the hydrogens. I see that I have 2 hydrogens here, and I have 1 hydrogen here. But wait, I actually have 2 hydrogens right here. Why is that? Because this coefficient. The coefficient applies to everything before which it is written. So I have 2 sodiums, 2 oxygens, and 2 hydrogens. Once again, that 2 tells me that if this is sodium, and this is oxygen, and this is hydrogen, there's 1 of them, and I have 2 of them. So this would be NaOH. I don't just have 1 of those, I have 2 of those. NaOH, something like that. So how many hydrogens do I have here? I have 2. So how many hydrogens do I have total on the reactant side, on the left side? I have 4. 1, 2, 3, 4. How many do I have total on the right side? I only have 2. How can I fix that? That's right. I add the coefficient 2. Now that gets me a total of 1, 2, 3, 4 hydrogens on both sides of the equation. Now let's check oxygens. I have 1, 2, 3, 4, 5 oxygens on the left. On the product side, I have 1, 2, 3, 4, 5 oxygens. Yay! This is perfectly balanced. This is a balanced chemical equation. You should always go back and check your work, count up every atom that you have on the left side, make sure it equals the number of elements and atoms that you have on the right side. Does this mean that I have to have exactly one of these combining with exactly two of these? No, but what it does tell me is that they must combine in a 1 to 2 ratio, and the products would then be created in a 1 to 2 ratio. What if I were asking you, you must be able to answer a question like this. If 6 particles of H2CO3 react with an excess of NaOH, how much H2O is produced? So first of all, let's talk about this word excess. If a question like this tells you that one of your reactants is present in excess, that means that you have way more than enough of it, more than you need to react. You have more than a 1 to 2 ratio of NaOH in your little beaker or wherever you're doing this reaction. So all I'm worried about then is how much H2CO3 I have, because I know I have more than enough NaOH. So if I have 6 of these guys, how many of these guys will be produced? If I have 6 particles of H2CO3, how much water am I going to produce? Well, to do this, I have to look at my recipe. I have to look at my chemical equation. My chemical equation says that for every 1 piece of H2CO3, I create 2 pieces of H2O. So, if I start with 6 pieces of this, how many pieces of H2O will I make? 12. It's a 1 to 2 ratio, so 6 times 2 would be 12. I would end up with 12 molecules of H2O. Here's another way of doing that. I can start with the information that I've been given, 6 particles of H2CO3, so I'm going to write that down, 6 H2CO3. And I know that according to my recipe, every 1 piece of H2CO3 will yield 2 pieces of water. So I'm going to write this down. My recipe tells me every 1 piece of H2CO3 gives me 2 pieces of H2O. The way this table is constructed, whenever things are next to each other, you multiply them, and whenever there's something on the bottom, you divide. So I multiply 6 times 2 to get 12, and I divide by 1, which is still 12. Daylight savings ends tomorrow. Extra hour of sleep. And then because I have H2CO3 showing up on the top and the bottom, it kind of works like a fraction. Whenever something shows up on the top and the bottom, it cancels out. So H2CO3 cancels out. And this tells me then that 6 times 2 divided by 1 is 12. 12 what? 12 H2Os, 12 pieces of H2O. So that's kind of another mathematical way of doing it. If you need to write down a math problem in order to solve these ratio questions, this is a great way of doing it.